Just give me a textbook. ಬರೀ ನಾನು ಅಪ್ ಟು ಡೇಟ್ ನೋಟ್ಸ್ ಕಂಪ್ಲೀಟ್ ಮಾಡ್ತೀನಿ, ಎಲ್ಲ ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಮಾಡ್ತೀನಿ ಅಂದರೆ ಆಗೋದಿಲ್ಲ. ಏನು ಬಾಯ್ಸ್ಗಿಂತ ನೀವು ಸಾಫ್ಟ್ವೇರ್ ಹೆಂಗೆ ಹೇಳ್ಬೇಕು ಅನ್ನೋದನ್ನ ಕಲೀರಿ. ರೋಡ್ ಮೇಲೆ ನಿಂತಿರ್ತೀರಲ್ಲ ಬಸ್ಸಿಗೆ, ಏನು ಚಿರಾಡ್ತೀರಿ, ಏನು ಶೌಟ್ ಮಾಡ್ತೀರಿ. ನಿಜವಾಗ್ಲೂ ಬಾಯ್ಸ್ ಸೈಲೆಂಟಾಗಿ ನಿಂತು ಕರೆಕ್ಟ್ ಬಸ್ ಮೇಲೆ ಹೋಗ್ತಾರ, ನೀವೇನು ಸ್ಕ್ರೀನ್ ಮಾಡೋದು, ಏನು ಶೌಟ್ ಮಾಡೋದು ಸರಿ ಅಲ್ಲ. ಒಬ್ರು ಮಾಡೋದ್ರಿಂದ ಎಲ್ಲರಿಗೂ ಬರ್ತದೆ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. ಕೆಲವು ಜನ ಹುಡುಗರ ಪಾಪ ಎಷ್ಟು ಕರೆಕ್ಟಾಗಿ ಬರ್ತಾರ, ಕರೆಕ್ಟಾಗಿ ಹೋಗ್ತಾರ ನೋಡಿ ಕಲೀರವರು. Yes, sir. Yesterday we will discuss the identities, right? Trigonometric identities. So first one, sin square theta plus cos square theta is equal to 1. And second one, 1 plus tan square theta is equal to sec square theta. And third one, 1 plus cot square theta is equal to cosec square theta. Okay, so first one I have proved yesterday, that is sin square theta plus cos square theta is equal to 1. So now we can take second one, 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. Okay, so same, every time we have to take a right angle triangle, draw one triangle ABC, right angle at B and angle formed at A, theta formed at A. So right here, in a right angle triangle ABC, in a right angle triangle ABC, angle B is equal to 90 degree. Angle B is equal to 90 degree. So according to Pythagoras theorem, how many have you proved this one? Boys, very few. Okay. According to Pythagoras theorem, in any right angle triangle, a square of hypotenuse is equal to sum of squares of other two sides. AC square is equal to AB square plus BC square. Correct? Yes. Now, here tan square theta is there. And here sec square is there. Means right hand side is a single term, left hand side two terms we have. Similarly, you can take it right hand side. So right hand side single term and left hand side we have two terms. So what is sec theta? How you define sec? Opposite. Hypotenuse upon adjacent. Cos theta is adjacent upon hypotenuse. Sec theta is hypotenuse upon adjacent. So here AC is hypotenuse, right? And which side is adjacent? Angle formed at A. AB is adjacent. So divide equation 1. Call it as equation 1. Divide equation 1 by AB square. Equation 1 by AB square. Because AB is a adjacent side. So now AC square upon AB square is equal to AB square upon AB square plus BC square upon AB square. So how I will write this? AC upon AB whole square. AB square cancel 1 plus BC upon AB whole square. So now AC upon AB. AC is hypotenuse side. Hypotenuse and AB is adjacent whole square is equal to 1 plus BC upon AB. BC is opposite side and AB is adjacent side whole square. Am I right? So what is the ratio of hypotenuse upon adjacent? The ratio hypotenuse upon adjacent is nothing but sec square theta is equal to 1 plus ratio opposite upon adjacent is nothing but tan square theta. So 1 plus tan square theta is equal to sec square theta. So this is the proof of second identity. Note down. Is finished? Yes, next, third one, 1 plus cot square theta is equal to cosec square theta. Third identity, 1 plus cot square theta is equal to cosec square theta. Explanation is same. In a right angle triangle ABC, angle B is equal to 90 degree and theta formed at A. According to Pythagoras theorem, AC square is equal to AB square plus BC square. Here, divide throughout the equation by, you want to tell? BC square. Why BC square? Because cosec square is nothing but what? Cosec theta is nothing but? Yes, hypotenuse upon opposite. Hypotenuse upon opposite. So hypotenuse is here. AC is the hypotenuse. But we have to divide by what? Opposite side. Hypotenuse upon opposite is nothing but cosec theta. So divide throughout equation by BC square. That is opposite side. So now AC square upon BC square is equal to AB square upon BC square plus BC square upon BC square. BC square get cancelled. So this is AC upon BC whole square, AB upon BC whole square plus 1. So AC upon BC is nothing but hypotenuse upon adjacent, correct? Yes, hypotenuse upon opposite. Hypotenuse upon opposite whole square is equal to AB square upon BC square, or AB upon BC whole square is nothing but adjacent upon opposite. Correct? AB is the adjacent and BC is the opposite whole square plus 1. Hypotenuse upon opposite is cosec square theta. Adjacent upon opposite is cot square theta plus 1. So 1 plus cot square theta is equal to cosec square theta is your third identity. Good. Is any doubts here? Any doubts? 12th last. Yes, we can take exercise number 8.3. First question. Express the trigonometric ratios sin A, sec A and tan A in terms of cot A. See, sin A we can express in terms of cot A. Sec A we can express in terms of cot A. Similarly, tan A we can express in terms of cot A. Yes. Till now we have learned trigonometric functions: sin theta, cos theta, tan theta, cosec theta, sec theta, cot theta, and some important relations. Sin theta is equal to 1 upon cosec theta, and cosec theta is equal to 1 upon sin theta. Sin theta is equal to 1 upon cosec theta. So similarly, cosec theta is equal to 1 upon sin theta, and cos theta is equal to 1 upon sec theta, and sec theta is equal to 1 upon cos theta, and tan theta is equal to 1 upon cot theta, and cot theta is equal to 1 upon tan theta. These are the some important relations. And one more, tan we can express in the form of sin and cos, that is tan theta is equal to sin theta upon cos theta, and cot theta is equal to cos theta upon sin theta. So after this we learnt standard angles. Sin 0 is 0, sin 30 half, sin 45 1 upon root 2, sin 60 root 3 upon 2, sin 90 1. Similarly, cos 0 1, cos 30 root 3 upon 2, cos 45 1 upon root 2, cos 60 half, cos 90 0. Then next tan 0 0, correct, 0 upon 1, tan 30 1 upon root 3, tan 45 1, tan 60 root 3, tan 90 not defined, infinity. So cosec is reciprocal of sin, and sec is reciprocal of cos, and cot is reciprocal of tan. So after this we learned trigonometric identities. So first identity, sin square theta plus cos square theta is equal to 1. Second one, 1 plus tan square theta is equal to sec square theta. And the third one, 1 plus cot square theta is equal to cosec square theta. So these many things we have learnt, correct? Yes. Now using all these relations, you can solve exercise number 8.3. Question number 1. First question: express the trigonometric ratios Sin A in the form of cot, sec A in the form of cot, and tan A in the form of cot. Yes. Sin A we can express in the form of cot. Yes, yes. See here, we have one relation, that is 1 plus cot square theta is equal to cosec square theta. 1 plus cot square theta is equal to cosec square theta. This is the identity. We know that right here. First one, we know that 1 plus cot square theta is equal to cosec square theta. So this is identity, third identity. So now cosec we can write in the form of sine. How? Cosec is a reciprocal of sine theta. So 1 plus cot square theta is equal to 1 upon sine square theta. Am I right? 1 upon sine square theta. So cross multiplication, sine square theta is equal to 1 upon 1 plus cot square theta. This sine square I took left hand side, and this 1 plus cot square transferred to right hand side. Am I right? Yes. Now sine theta is equal to under root 1 upon 1 plus cot square theta, or you can write this as 1 upon under root 1 plus cot square theta. So sine theta in the form of cot, sine in the form of cot. Am I right? Yes. Similarly, sec A in the form of cot. Where is sec? Yes, sec is there here. So second identity we can use. Second one, sec A. We know that 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. But they asked to write in the form of cot, but it is in the form of tan. But we know one more relation, 1 upon cot theta is equal to tan theta, and cot theta is equal to 1 upon tan theta. So this tan you can write in the form of cot. Tan is a reciprocal of cot. So 1 plus 1 upon cot square theta is equal to sec square theta. Am I right? Yes. Now take LCM here. LCM is cot square theta. LCM is cot square theta. Cot square theta into 1 is cot square theta plus 1 is equal to sec square theta. But they asked sec theta, not a sec square theta. Okay. So now sec theta is equal to under root 1 plus cot square theta divided by cot square theta. Here we can separate the roots. Square root is both numerator and denominator. So we can separate the roots. Sec theta is equal to under root 1 plus cot square theta divided by cot theta. Then third one, they ask tan A or tan, sorry, yes, you can make it A, not theta. A you can make, okay? Everywhere all the angles A. Not to theta, A. Okay. So now tan A in the form of cot A. Yes, can anyone tell the answer? Tan A. Simple, 1 upon cot A. So tan A is equal to 1 upon cot A. Tan A in the form of cot A. So sin A in the form of cot is 1 upon under root 1 plus cot square A. And sec A in the form of cot is sec A is equal to under root 1 plus cot square A divided by cot A. And tan A is 1 upon cot A. Understood? Check in answer sheet. Am I right? Yes, no. Is finished? Hold on fast. Okay, second question. Write all other trigonometric ratios of angle A in terms of sec A. Here, sin A we expressed in terms of cot A, and sec A we expressed in terms of cot A, even tan A also expressed in terms of cot A. But in second example, you can express all trigonometric functions. All means how many are there? 6 are there. Huh? 6 means sec is sec only. So only 5 remain. So express all 5 trigonometric ratios in the form of sec, in terms of sec. First one is sin A. Sin A we can express in terms of sec sin A. First one. See here. See the identity. Sin square theta plus cos square theta is equal to 1. Can we express cos in the form of sec? Yes, easily. 1 upon sec is cos. So we can take a first identity. We know that sin square theta, here A, not theta, sin square A plus cos square A is equal to 1. Sin square A plus cos square A is 1. Sin square A is equal to 1 minus cos square A. Sin square A is equal to 1 minus cos square A. But they ask to express in the form of sec. So cos we can write it as 1 upon sec square A. Cos theta is nothing but 1 upon sec theta. So now we can take LCM. LCM is sec square A. Cross multiplication. Sec square A minus 1. So sin square A is equal to sec square A minus 1. Sin A is equal to under root sec square A minus 1 upon sec square A. So sin A is equal to under root sec square A minus 1 upon sec A. Square root get cancelled upon sec A. See, sin in the form of sec. Next, cos also in the form of sec. Cos A. Yes, cos A is equal to 1 upon sec A. Simple. Cos A is equal to 1 upon sec A. The next third one, tan. Third one, tan. Tan A is equal to, yes, tan A. We know the relation. 1 plus tan square theta is equal to sec square theta. So we know that 1 plus tan square theta is equal to sec square theta. A. Angle A, not theta. Okay, 1 plus tan square A is equal to sec square A. So tan square A is equal to sec square A minus 1. This one moves to right hand side. But they ask tan, not tan square. So tan A is equal to under root sec square A minus 1. Tan in the form of sec. Am I right? Yes. Now, fourth one. Which one? Cosec. Reciprocal of sin is cosec. So we can reciprocal this. Cosec A is equal to sec A upon under root sec square A minus 1. Sec is sec only. Then last one is cot. Reciprocal of tan is cot. 1 upon under root sec square A minus 1 is cot. Simple. Check in answer sheet. Am I right? Yes, no. You don't think that you will reteach this. No. This is the final. Keep in your mind. Few of them are simply for enjoyment coming here, not serious at all. Actually, you can. This minute is very well. Huh? You went to? Yeah? Huh? वो बॉल भी also present except Ananya Bansi. Huh? Is any doubts here? Well, any doubts? Boys, Puttur, hey. Yesterday one of your friends made a phone call to school number. Pranav, who is Pranav? Don't say that. Don't. Now only I will make a phone call and I will do it. Pratik Naik. Who is Pratik? You go place. You don't know it's a school number. Huh? Such a dumb fellow you are. He made a call and asked him, sir, Soham Iran. School number it is. It's finished? Okay. Next question number 3. Choose the correct option. Justify your choice is the question. Do you have any doubts here? Last, any doubts? Prem Dundapur. Better you have to sit with this circle, man. Huh? You know there is one English proverb. If you spend a time with 5 successful people, maybe you are the 6th one. If you spend a time with 5 billionaires, maybe you are the 6th one. If you spend a time with 5 good people, maybe you are the 6th one. If you spend a time with 5 losers, maybe you are the 6th one. Right? Your circle decides who you are. Third one. Choose the correct option. Justify your choice. 9 sec square a. 9 times of sec square a minus 9 times of tan square a is equal to question mark. Option A is 1. Option B is 9. Option C is 8. Option D is 0. So let's solve this example using the identities. We have 3 identities. The first one is sin square theta plus cos square theta is equal to 1. Then second one 1 plus tan square theta is equal to sec square theta. So in place of sec square a, I can take 1 plus tan square a. Okay? Because 1 plus tan square theta is equal to sec square theta. So solution or justification you can write 9 into bracket. So instead of sec square a, I will take 1 plus tan square theta. 1 plus tan square a minus 9 times of tan square a. So multiply here, 9 ones are 9 plus 9 tan square A minus 9 tan square A. So plus 9 tan square A minus 9 tan square A get cancelled and the remaining term is only 9. Hence the right option is B. Note. Is finished? Okay, next second one. 1 plus tan theta plus sec theta. 1 plus cot theta minus cosec theta. Second question. Second one. 1 plus tan theta plus sec theta. 1 plus cot theta. 1 plus cot theta minus cosec theta is equal to question mark. Options are given. Option A is 0, option B is 1 and option C is 2 and option D is minus 1. Yeah, see. Solution or justification. 1 plus tan theta plus sec theta. Here tan is there, sec is there. There cot is there and cosec is there. So we can write this 1 plus tan theta, sec theta in the form of sin and cos. In the form of sin and cos. So 1 plus tan theta is nothing but sin theta upon cos theta and sec theta 1 upon cos theta. Am I right? Yeah, similarly, 1 plus cot theta is cos theta upon sin theta minus cosec is 1 upon sin theta. Am I right? Yes, we can take the LCM. This is the first term and this is the second term. In first term, the LCM is cos theta. In first term, the LCM is cos theta. So cos theta is the LCM. So you have to multiply with cos here. Here already cos are there in denominator, so no need to multiply any number. So cos theta into 1, cos theta plus sin theta plus 1. So similarly, here sin theta is LCM in second term. Here 1 is there, so multiply with the sin theta. So cos theta plus sin theta I will write. It is actually sin theta plus cos theta. Is nothing but cos theta plus sin theta minus 1. See the numerator. Numerator looks like this is A and this is B. This is A and this is B. A plus B into A minus B. A plus B into A minus B. So we take it as cos theta plus sin theta whole square minus 1 square. Expansion of A square minus B square is A plus B, A minus B. So this whole term cos theta plus sin theta you can consider it as A and 1 as a B. So this is A plus B, A minus B. Correct? So A plus B into A minus B is nothing but A square minus B square. And denominator write as it is. That is sin theta into cos theta. See the numerator. Cos theta plus sin theta whole square is in the form of A plus B whole square. So the expansion of A plus B whole square, A square plus B square plus 2AB minus 1 square is 1 divided by denominator as it is sin theta into cos theta. You know the identities, sin square theta plus cos square theta, what? 1. Sin square theta plus cos square theta is nothing but 1. So can I write sin square theta plus cos square theta 1? Yes, 1 plus 2 times of sin theta into cos theta minus 1 divided by sin theta into cos theta. Plus 1 minus 1 cancel. Remaining term only 2 sin theta into cos theta. 2 sin theta into cos theta divided by sin theta into cos theta. So sin theta cos theta get cancelled. Remaining term only 2. Hence option C is right answer. Got it? So any doubts? No doubt. Finish. If you want to become a genius in trigonometry, only the solution is what? Practice. More you practice, more you will learn. More you will become genius. Even without seeing any textbook and all, I am solving all these things because I know all the identities, I know all the basic concepts, I know the tactics, I know the tricks. How it came? Practice. Hope you are solving only one time in a year. Maybe thrice or 4 times I am teaching. 3 divisions are there. 3 times. Along with that one vacation class. 4 times I am teaching. Yes, I will become a master. If you practice more, even you too become a master. Understood? More you can practice. Okay? Yes, sir. The next example number 3. By tomorrow you will get the worksheet of this introduction to trigonometry. This is the last exercise. Third one, sec A plus tan A. Sec A plus tan A into bracket 1 minus sin A. Into bracket 1 minus sin A. Sec A plus tan. See here, always the sec, tan and cotrigonometric functions try to convert in the form of sine and cos. It is a simple way, okay? Complex into simple. So sec we can write 1 upon cos A and tan sin A upon cos A. Into bracket sine, it is always in the already in the form of sine, you can write as it is 1 minus sin A. No need to write and no need to convert this into a cosec or convert this into a cot. Okay, yes, now here cos A is a LCM. Take cos A as a LCM. 1 plus sin A right as it is, 1 plus sin A, and this 1 minus sin A right as it is, 1 minus sin A. See the numerator. Here 1 plus sin A, here 1 minus sin A. It looks like in the form of A plus B into A minus B. Yes, it seems. So now A plus B into A minus B is nothing but A square minus B square divided by cos A. A square minus B square. 1 minus sin square A divided by cos A. See the identities. Sin square theta plus cos square theta is equal to 1. 1 minus sin square theta is equal to cos square theta. So can I write 1 minus sin square as a cos square A? Cos square A divided by cos A. 1 cos A, 1 cos A get cancelled. Cos A. Option is there? Which option? Option B. D. Yes. Note. This last one, fourth one. 1 plus tan square A. Fourth one. 1 plus tan square A divided by 1 plus cot square A. Let's see the identities. Second identity, 1 plus tan square theta is equal to sec square theta. Correct? So here 1 plus tan square A is there. 1 plus tan square A is nothing but sec square A. Sec square A. And 1 plus cot square theta is equal to cosec square theta. So 1 plus cot square A is cosec square A. Cosec square A. Sec square we can write in the form of cos. Sec is the reciprocal of cos and cosec is the reciprocal of sine. So this multiplies to numerator and this multiplies to denominator. So sin square A into 1 is sin square A. Cos square A into 1 is cos square A. Sin upon cos is nothing but tan. Square is there. So tan square. Tan square A. Option D. Tan square A. Is finished? Okay. Next, fourth main. Prove the following identities where the angles involved are acute angles for which the expressions are different. So these all questions, weightage is 3 marks, all questions. And these are all important questions. Fourth main, first question, cosec theta minus cot theta whole square is equal to 1 minus cos theta divided by 1 plus cos theta. This main is very important, fourth main. Every year one fixed question based on the fourth main. Okay? Yes. Cosec theta minus cot theta whole square is in left hand side. 1 minus cos theta upon 1 plus cos theta we can prove. Is any idea how to prove? That only LHS is equal to RHS we can prove. So we can take first LHS and we can prove RHS, or we can take RHS, prove LHS. Yes. Yeah, LHS we can take solution or proof. LHS is cosec theta minus cot theta whole square. So cosec and cot you can write in the form of sin and cos, because the right hand side is in the form of cos. So cosec theta is 1 upon sin theta minus cot theta is cos theta upon sin theta. Am I right? Whole square. So now LCM is sin theta. Sin theta into 1 minus cos theta whole square. Now I will separate the square. For numerator 1 minus cos theta square, for denominator sin square theta. Sin square theta. Now come to the identities. First identity you can see. Sin square theta plus cos square theta is equal to 1. So sin square theta can also write as 1 minus cos square theta. So numerator write as it is 1 minus cos theta whole square divided by 1 minus cos square theta. 1 minus cos square theta. See, numerator looks like a square minus b square. This is 1 square. Imagine this is 1 square. 1 square is 1. A square minus b square. A square minus b square is nothing but numerator write as it is 1 minus cos theta whole square. A square minus b square is nothing but a plus b into a minus b. 1 minus cos theta, 1 minus cos theta get cancelled. Here 2 are there, here 1 is there. So get cancelled. So remaining term 1 minus cos theta divided by 1 plus cos theta. This is your RHS. Hence the proof. Yes, second one. So do you have any doubts here? Second example. Cos A divided by 1 plus sin A. I think this example appeared 3 to 4 times in a board examination. Important. Cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 times of secant. 2 times of secant. Okay. Here already the functions are in the form of cos and sin. Solution, directly we can take the LCM. First LHS side. LHS is cos A upon 1 plus sin A plus 1 plus sin A divided by cos A. Already functions in the form of cos and sin, so no need to convert to secant, cosec or tan, whatever it is. Okay, yeah. So denominators are different. Here 1 plus sin A and here it is cos A. So we can take the LCM. So the LCM is, what is the LCM? Cos A into 1 plus sin A. Here 1 plus sin A is there, but cos A is not there. So you have to multiply with cos A. Similarly, here cos A is there, but 1 plus sin A is there, not there. So 1 plus sin A we have to multiply. So cos A into cos A, cos square A plus 1 plus sin A into 1 plus sin A, 1 plus sin A whole square. Cos square A plus 1 plus sin A whole square. So now cos square A write as it is. Cos square A plus, look at this, 1 plus sin A whole square. It is in the form of A plus B whole square. So the expansion of A plus B whole square, A square plus B square plus 2AB. So 1 square plus sin square A plus 2 into 1 into sin 2AB. 2 into A into B divided by cos A into 1 plus sin A. Am I right? Now cos square A plus sin square A is nothing but 1. Rather than cos square A plus sin square A, I will write 1. 1 square 1. So remaining terms, only last term is remain. Plus 2 ones are 2 into sin A, 2 times of sin A divided by cos A into 1 plus sin A. 1 plus 1, 2. 2 plus 2 sin A divided by cos A into 1 plus sin A. 2 is common in numerator. Am I right? 2 is common in numerator. Take it outside. 2 into bracket 1 plus sin A divided by cos A into 1 plus sin A. 1 plus sin A, 1 plus sin A get cancelled. Remaining term in numerator 2, in denominator cos. 2 into 1 upon cos A. 1 upon cos A is nothing but sec. 2 times of sec A is your RHS. Okay. Yes, sir. Do you have any doubts here? Boys, any doubts? Yes, next question. Question number 3. Third question. Tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus sec theta into cosec theta. 1 plus sec theta into cosec theta, and what hint they have given? Write the expressions in terms of sin theta and cos theta. So we know that tan theta is nothing but sin theta upon cos theta. So LHS is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. Let's write LHS side. So express tan and cot in the form of sin and cos. Tan theta is nothing but sin theta upon cos theta whole divided by cot theta is nothing but 1 minus cos theta upon sin theta plus cot theta is nothing but cos theta upon sin theta whole divided by 1 minus sin theta upon cos theta. See here, it became complicated, right? Sin theta upon cos theta, 1 minus cos theta upon sin theta, cos theta upon sin theta, 1 minus sin theta upon cos theta. So we can take LCM in denominator. So here 1 and sin theta, 1 and sin theta, LCM is sin theta. Here 1 and cos theta, LCM is cos theta. So again you have to write everything as it is. You have to write sin theta upon cos theta whole divided by, so here LCM I took, that is sin theta. LCM is sin theta. Here 1 is there, so numerator is 1, multiply sin theta with 1, you will get sin theta minus cos theta plus cos theta upon sin theta whole divided by, same LCM is cos theta minus sin theta. Okay, so now I will multiply sin theta to numerator and cos theta to numerator. So sin theta into sin, that is the rule. If you know the rule, A upon B whole divided by C upon D. Numerator, denominator. So always here A multiply with D and B multiply with C. This rule you know, correct? Yes. Similarly, this sin theta I multiply with sin theta. Sin theta into sin theta, sin square theta, and this sin theta minus cos theta I multiply with cos theta divided by cos theta into sin theta minus cos theta. So plus cos theta into cos theta, cos square theta divided by this sin theta into cos theta minus sin theta. Okay, yes. Now see here, sin square theta upon cos theta into bracket sin theta minus cos theta. Cos square theta upon sin theta, cos theta minus sin theta. Here sin theta minus cos theta, here cos theta minus sin theta. Terms are not same. make the terms are same. See, if you take LCM, what you will get? Sin theta into cos theta, sin theta minus cos theta minus sin theta. Again it becomes complex. So that's what you do. You take minus sign common here, make this term cos theta minus sin theta as a sin theta minus cos theta. If you take minus sign common, what you will get? Minus into minus plus sin theta will get, and plus into minus minus cos theta will get. Am I right? Yes. So in next step you can take minus sign common. Numerator write as it is sin square theta upon cos theta into bracket sin theta minus cos theta. Here I took minus sign common now. Plus become minus now. I took minus sign common. Cos square theta write as it is. Cos square theta divided by sin theta also as it is into bracket. I took minus sign common. So this minus become plus, minus into minus plus sin theta plus into minus minus cos theta. Now you can see the denominators almost same, 90% same. Sin theta minus cos theta, sin theta minus cos theta. Only cos and sin are different. So now we can take LCM. LCM is sin theta into cos theta into sin theta minus cos theta. So already here cos theta into sin theta minus cos theta is there. So we need to multiply with sin theta. Am I right? Yes. Sin square theta into sin theta, cos square theta into cos theta. Sin square theta into sin theta, sin cube theta minus cos square theta into cos theta, cos cube theta. Again algebraic identity is here. A cube minus b cube. What is the expansion of a cube minus b cube? A cube minus b cube is equal to a minus b into a square plus ab plus b square. Learn identities. Yes. So a cube minus b cube is nothing but a minus b into a square plus what? AB into b square cos square theta. Am I right? So divided by this term right as it is, sin theta into cos theta into sin theta minus cos theta. So now sin theta minus cos theta, sin theta minus cos theta get cancelled. Sin square theta plus cos square theta is nothing but 1 plus sin theta into cos theta divided by remaining term is sin theta into cos theta. Now separate the denominators. 1 upon. Sir, is it possible to cancel sin theta into cos theta? Sin? No, because it is not a single term in numerator. Here you are adding with 1. Okay. So now we can separate the terms, separate the denominator. 1 upon sin theta into cos theta plus sin theta into cos theta upon sin theta into cos theta. Sin theta cos theta, sin theta cos theta get cancelled. 1 upon sin is nothing but cosec. 1 upon sin is cosec theta. Then 1 upon cos sec theta plus 1. So 1 plus sec theta into cos sec theta is your RHS. So this is your RHS. Note down. Any doubts here? Next example. Write these identities. A cube plus b cube is equal to a plus b into a square minus ab plus b square. A cube minus b cube is equal to a minus b into a square plus ab plus b square. Don't get confused. A cube plus b cube is equal to a plus b into a square minus ab plus b square, and a cube minus b cube is equal to a minus b into a square plus ab plus b square. Important identities, algebraic identities. Okay, can we take next example? Fourth one, last question of this session. 1 plus sec a divided by sec a is equal to sin square a upon 1 minus cos a. Hint, simplify LHS and RHS separately. Here no need to prove. You have to simplify LHS separately and RHS separately. If LHS is equal to RHS, then your answer is correct. Okay? Yes. Fourth one, 1 plus sec a plus sec a divided by sec a. This is the fourth one. Is equal to sin square a upon 1 minus cos a. These they are given. Take LHS and RHS separately and simplify. So LHS we can take now. LHS 1 plus sec a divided by sec a. 1 plus sec a divided by sec a. So always you remember, these are called co-trigonometric. Sec, cosec and cot are called co-trigonometric. So try to express in the form of sin and cos. Sec, cosec, tan, cot, you can try to express in the form of sin and cos. So here also sec is there. So you can express in the form of cos. Sec is 1 upon cos plus 1 upon cos. Correct? So you can take LCM in numerator denominator. So two denominators are here, 1 and cos a. So the LCM is cos a. Cos a into 1, cos a plus 1 divided by 1 upon cos a. I told you, this multiplies to numerator and this multiplies to denominator. So cos a into 1 plus cos a or cos a plus 1 divided by cos a. 1 into cos a. Cos a cancel. 1 plus cos a is your answer here. Now we can check RHS. RHS side, sin square A divided by 1 minus cos A. So we know the identity. First identity, sin square theta plus cos square theta is equal to 1 and sin square theta is equal to 1 minus cos square theta. So rather than sin square A, I can write as 1 minus cos square A and denominator write as it is 1 minus cos A. See the numerator. So numerator is in the form of A square minus B square. 1 square is 1. So A square minus B square. So the expansion of A square minus B square is A plus B into A minus B. Again denominator write as it is, that is 1 minus cos A. Now 1 minus cos A, 1 minus cos A get cancelled. So remaining term only 1 plus cos A. Even in LHS also it is 1 plus cos A, even in RHS also it is 1 plus cos A. Therefore LHS is equal to RHS, hence verified. Not proved here, hence verified. Okay? Let's note. Do you have any doubts here? Girls? No doubts? Okay. You can take 10 minutes rest. Panda sir will continue the class.